Hi, welcome to Tech Demo 2. This is James, and the task for this tech demo is to plot this figure, this surface, on the graph given by this formula, the first formula, and find its corresponding tangent plane at the point x equals to 2, y equals to -1, and z equals to -3. And let's take a look at this figure right now. Zoom out a little bit. So we've seen that there is kind of like a nod shape made at z equals to 0, and we'll see that later in the contour plot as well. And this is the surface. Looks quite weird, but it's given by the formula. And this is the tangent plane after a calculation. And I will show you how I computed the tangent plane at this certain point of this graph. So let's take a look at it. This formula is given by f of xy of two variables equals to 1 over 2x cubed minus y cubed plus 4xy. And in order to find the tangent plane without z being explicitly defined, or in R4 basically, we'll have to find the linearization of z. And that is given by this formula. F of x naught y naught plus the partial derivative of x at that point times x minus x naught plus the partial derivative of y times y minus y naught. So by plugging in x naught equals to 2 and y naught equals to -1, we're going to get a formula for this tangent plane. And this is described by this 2x plus 5y minus z equals to 2, just by doing some simple algebra. And then we can do a sanity check if this plane and this surface both pass through this point. In order for them to be tangent at that point, they have to both pass through that point. By plugging in 2, -1, and -3 into the both equations, you're going to get left-hand side equals to right-hand side. And that is going to tell us this point might be the one that we're looking for where this plane is tangent to this surface at this point. So now we can take a look at calcplot 3D in order to look at the contour plots for the two graphs. So equivalently, we have this surface, which is, uh, okay, this looks more similar to the one that we had in Desmos. And this is the surface, right? And if you can see, I'm not sure if this is presented clear enough, but um, they both pass through the level of, well, they cut each other basically at the level of z equals to -3, which is the z coordinate we're looking for. But it will be more obvious if we plot this contour plots for the two graphs, and this is what we're going to get. And by zooming in a little bit, we're going to have a better look at the numerical value. So we can see that the nod shape, right? That this let me remove the one for the plane first, and we can look at this graph. So at 0 marked over here, look at the mouse. There is a nod shape made, and there is an intersection of the figure itself at this origin, which is quite interesting. And as they extends, this contour plots they converge into sort of a one line on both sides of the two graphs. So that's the interesting part of this contour plot. And by also adding in the surface, we can see that there are certain points of the two where the two contour plots intersect, and there are even fewer points, and given by this and this point over here, the 2 points, I'm gonna mark it so it's clear, more clear, when x is equivalent to 2 and when y is -1. So this is the point where we're looking for, right? And we can see that on this line it marks z equals to -3. So this is exactly the point that we're looking for. Why are they tangent? Well, this is proving the fact that the plane is tangent to this surface at this point because their contour plots are tangent to each other. That means the gradient of the plot is pointing towards the same direction as the gradient of the surface, this plane. And that's how we know that this plane works as a tangent plane for this graph. And that will be all for Tech Demo 2. Thank you for watching.